That is why. Okay, I am sharing my screen now. So if you're seeing my screen, you should see a question, and I guess I want your initial reaction to like a question like this. Like, what do you notice? What stands out?
And before I read it, I think I know I'm gonna write stuff on the side. Because a word problem, all the information you need to remember.
So you said something very important there, that this is a word problem.
Yeah.
Okay. What do you notice about the answer space? Are there any numbers here?
Yeah.
There are some numbers, but most of it is letters. So we would consider this symbolic.
Okay.
So yeah, you'll definitely want to use, this space to work out the problem.
Mm.
All right, now I'm actually going to copy this into, and we're going to look at it fresh. So I'll read it out loud. A bakery in Oakland makes brownies on Fridays and truffles on Saturdays. Brian can make Y brownies per hour, and Zach can make R truffles per hour. Brian only works 7 hours on Fridays, and Zach only works 4 hours on Saturdays. Which of the following expressions describes the number of weeks N needed to produce J baked goods made by the pair?
So I'm just gonna take a screenshot of this, and
Absolutely.
so I can look right on it. I got my Apple Pencil. Okay.
Let me know when you're ready.
Okay, I'm sorry. I'm start reading it one more time.
Sure.
Is it D?
Well, before you just jump to answer it, because the thing that one of the things that I'd like to do here is I'd actually like to help you work through it. Have you heard of distance equals rate times time before?
No.
So rate is like this. Let's say you're on an interstate and you were going at 60 miles per hour, and you travel for 1 hour. How far have you gone?
60 miles.
60 miles, right? So your rate, this is your rate, the 60, and your time is the time, the hours. This equation here doesn't just apply to like driving, it applies to any sort of rate. So when it says here that Brian can make Y brownies per hour, okay, and Brian works 7 hours, what is Brian's total?
Well, 49.
Well, 7 times Y.
Yep. But if he worked every day,
Well, but he doesn't. It says he only works on Fridays, only.
Oh, yeah.
Okay. Now let's see if we can do the same thing for Zach. I'll switch colors for Zach here. So what's going on with Zach? Well, Zach makes our truffles per hour. And Zach works 4 hours. So what is Zach's total? 4R.
4 hours, and how much does he get done? How many hours does he do in a month?
It's just a week. We just care about the number of, we just care about the weeks.
Just 4?
Well, 4R, because we don't know how many truffles he makes per hour. If he made 10 truffles per hour, it'd be 4 times 10. So this is an example of a symbolic problem where you don't have numbers. You don't know the values. You just know that it's 4R and 7Y.
Yeah.
So in 1 week, how much do they make in 1 week?
Combined?
Yep.
11 hour.
But it's 7Y. 7Y plus, I'm sorry, plus 4R.
So 11 RJ.
Well, you can't
RY.
you cannot combine these. These are different variables, so you cannot combine them.
7Y plus 4R.
It is just itself, 7Y plus. So now, if they work, so this is for 1 week. Do you agree with that?
Yeah.
If they worked 2 weeks, what would change? What would this become? The 7Y if it was 2 weeks?
14.
Say that again. 14Y plus, what does this become?
8R.
Okay. And how about 3 weeks?
21R and 12R.
Yep. Now, how about N weeks? So this is where you got to go back and look like, what did you do to this thing right here to get to the second week? And what did you do to get to the third week? What did you multiply by? So do you see how you multiplied everything by 2 to get to 2 weeks?
Yep.
And then you multiplied it by 3 to get to this one right here.
Yes.
So if you multiply by N, you get this 7Y plus 4R.
Because you don't know what it is.
We don't know what it is. Now we want to make, or they're supposed to produce J goods. And now we need to solve for N. So to do that, we divide both sides by 7Y plus 4R. So if you divide the top and bottom by the same thing, whether it's a number or a variable, it goes away. Is that okay? Is that clear?
Yes.
So N is J over 7Y plus 4R. So while you're looking that over, I'm going to go find some more questions, but let me know what questions you have. The difficulty isn't in the manipulation of the numbers, it's in the combining of variables.
Yeah.
All right, so let's see what we got here. This is, I don't even know what week we're on. Okay, let me go figure out what week we're on. All right, so 45, so 23. Let's go to 23. All right, so let me give you, I found what I wanted here. Let me give you another problem here, but I will not aid you with the answer key. We'll do it without the answer key here. So let's grab another question. All right, so here's your new question, Craig. Oh, I said I would do it with, well, we'll leave one up with the multiple choice, then we'll do it without. All right, so go ahead and start on this question. I'm going to time you here. We'll see how you do. And let me know when you got an answer, please.
Okay. Oh, and what was the answer for the last one again?
Might have been B. Yeah, it's B. It was B.
Okay. Okay, so is it C?
So it's gonna basically take on the same form as the previous one, which is what makes after seeing one or two multiple choice not too bad. So it's J. Jeremy is J times 12 or 12J. Logan is K times 9, 9K. So it's N12J plus 9K equals H baked goods. So you divide both sides by 9K to get the correct answer, which is letter, sorry, it's letter C. Not sure which, I don't remember if you said C or not.
Oh yeah, I should.
Okay. Wait, let's try another one here, but this time I will not give you the answers. We'll see if you can do it. In terms of your time, I did some talking. I didn't catch the timer, of course, quite right. I mean, you did it pretty fast. We'll say a minute and 15 seconds. Okay, so here's a new question. Go ahead and go ahead and start on that, please.
So it would be S on the top, and then a line,
Divided by, we would say S divided by,
and then K or 3K
3K.
plus 4F.
Exactly, perfect. Perfect. Okay, so not too difficult. Now that you see the style, right, you can just do as many of these as you want, and you can get the answer. So the other question that I wrote that goes along with these is very similar. Okay, so let me snip in question one here, and we'll you'll notice right away that's it's slightly different, but retains a lot of the same things here. So go ahead and read that and see if you can solve it on your own. I bet you can.
But that's deep.
Okay, so let's take a look at this together. It's pretty much the same setup here. Casey makes K sweet rolls per hour, and he only works 6 hours, so that's 6K. And then Peter P truffles, but he works 3 hours, so 3P. Okay, and that's for 1 week. So in 1 week, C plus P is 6K plus 3P. But how many weeks are they working?
Well, 4 weeks, but they only work on Thursdays and Saturdays.
Right, but that means this is 1 week. So 2 weeks would be 12K plus 6P.
Oh, is it A actually?
Yeah, but so let's talk about how we could shortcut this, because you don't want to be writing this out on there. How
Six.
do you see how
Six.
you could have multiplied the original expression by 4
Yes.
to get this?
Yeah.
Okay, so let's try another one here.
Yeah.
Let's just pick something a little more random. No. About this one. Okay. All right, so here's your question. Let's see if you can do this in under a minute, okay?
All right.
Go ahead and start, please.
All right. All right, so that's A, but I took a little longer because I did 10 times 5 and then 3 times 5, and then I didn't see the answer on there. And then
Yeah, and that's one of the challenges with these multiple choices. If your answer isn't on there, what are you going to do? And one strategy is to rework the problem, which is really the right one. You don't want to try to make something work. You want to go back. You almost want to ignore these in some situations and just see like, well, what is the right answer? So Ricardo is Z times 10 or 10Z. Vanessa is P times 3 or 3P. And they're going together. So 10Z plus 3P times 5. And that's where the 50Z plus 15P comes in. All right, let's do one more. This time I am not going to give you the answer, so you got to come up with the answer on your own.
okay.
Let me just get this frame better. There we go. Go ahead.
All right. All right, so that's gonna be 27z plus 36m.
Yeah, so we got Alex is M times 12 or 12M. Jeff is Z times 9 or 9Z. And then we add those together. Or I'm sorry, we add those together and multiply by the number of weeks, which is 3, 36M plus 27Z. Right. So any questions on that or any kind of thoughts on that question?
I got it right, correct?
Yes, yes. But any questions or anything on that
No thoughts on it. On the last question, when I was like, I didn't see my answer on there, and then when you went over it with me, and the answer was 15, plus 15.
Mhm.
Then I was just being like, I don't know why I didn't see that, but that was the answer I was trying to put.
Great. So there are these things called literal equations, and I want to just tackle a few of those for the moment here. Literal equations is the math name for it, but it's something like this. It's like ax plus by equals c, and they ask you to solve for y. So this is given, and they want you to solve it for y. Have you seen something like that before?
Well, you don't have any information though.
Right, but so like as a student here, watch this. If I do this, 3x plus 6y equals 12, and I ask you to solve for y, you might subtract 3x from both sides. So you'd have 6y equals 12 minus 3x. Is that okay? Have you seen that before?
6y equals, have I seen that? Wait, let me try and solve that to check.
Well, there's still one more step. I'm asking, like, have you seen moving terms from one side to the other?
Oh yeah.
Okay. So then the next thing to do is divide by 6. So this gives you y equals 12 divided by 6 minus 3x divided by 6. And then you can divide each of these. So 12 divided by 6 is 2, 3 divided by 6 is 1/2, and this is your final answer. So remember, the original question said solve for y. That means to get y by itself. So let me know when you get this copy down. I think we should spend a little more time on some literal equations like this.
One sec. Okay.
All right, so let's try another one here. Let's say I give you an equation like this: 4x plus 8y equals 16. Could you try solving this for y?
Yes.
Okay, give that a try, please.
So it'd be y equals 2 plus negative half x.
like this. On the right here, does that look right?
Yeah.
Okay, let me just work this out here. Now there's a convention here that I didn't tell you about, which is you actually prefer to put the X term first. There's just a preference for that. So when you divide by 8 on both sides, you get y equals -1/2 x plus 2. And these are the same. So you got this right, okay? These are the same, but there's a preference here for putting x first.
Okay.
Okay, so let me give you another one here. -3x plus 4y equals 12. Try solving that, please.
So that'd be y equals 3, and then whatever, and then whatever 3 divided by 4 is.
So it's okay to write it this way. 3 divided by 4 times x. Plus, what number goes here?
3.
Yes. So this is okay. You don't have to convert it to a decimal. It's a fractions are okay. Fractions are okay. All right, so let's try another one here. This one's gonna get a little bit more difficult. -4x minus 2y equals 6. Can you do the same thing here? Can you solve this for y?
Mm-hmm. So y equals -3 plus 4 on the bottom, and has a fraction like 4 on the bottom and 2 on the.
I think you've got a little bit awry here. Let's just take a look at this one together. You undo -4x by adding 4x. So that's -2y equals 4x plus 6. Okay, and then see how there's a -2 in front of y? You divide both sides by -2. And what that means is you're dividing each of these by -2.
Yep.
Okay. So now what is 4 divided by -2?
-2.
Okay, what is 6 divided by -2?
-3.
Right, and then if you want, you can write it this way, -2x minus 3 or -2x plus -3. Either way, like that is good. Okay, let's do another one here. -5x minus 10y equals 15. Nope, I'm sorry. Let me choose a different number here. Let me go 5y here.
Alright, so y equals -3 plus -5 on top and 2 on the bottom.
Okay, let's look at this again. Let's get this together. So you're gonna add 5x to both sides. So it becomes -5y, and Matthew said,
Wait, one second. I'm doing this in my head, so
yeah, don't do that. You got to write this down.
is it just 1?
Well, we're gonna divide both sides by -5. So you're dividing each term, these are a term, you're dividing each term by -5.
So is it -1 plus negative?
It's -1x minus 3.
Okay.
Now, again, like this is very important. It's considered preferred to put the x variable first, -3.
Yeah.
Okay, let's try another one here. You gotta write this down, Craig. Even it's just it's a necessary step for doing this. So let's go -9y. I'm sorry, -9x plus 3y equals -12. And I want you again solve for y.
Wait, where's your backpack? No, time out. Go get your backpack.
Hey, Rick.
Yeah. Hey, he was doing something on like a Post-it note. I'm like,
Okay.
come on. You know, like,
Yeah,
dude, get a real piece of paper. Like, what you doing?
Sorry
He
about
tries to
that.
do so much.
I normally ask the student, hey, pencil and paper out, but I just wrongly assumed he had it today. So
No, that's all right. He just tries to do so much in his head.
yeah, it
And
doesn't
at a
work.
point, you need to be doing it. And plus they want to see you work too, right?
It builds good habits. Yeah.
Okay.
Okay.
Is it blank? Back? Okay, go ahead. All right, we're ready now.
All right. Hey, Craig. So whenever you're ready, go ahead and write this problem down, and please just show your steps. I mean, I'm looking for about the same work that I'm showing you here, but I think you'll avoid the sign errors and the issues. So go ahead and work that out and let me know when you're all done, please.
Okay. Okay. I think it's y equals -4 plus 3x.
Y equals -4 plus 3x like this. Is that right, Craig?
Yeah.
Okay, so again, it's really important that you put the variable first, the variable term first.
Oh, yeah.
Okay, so let's take a look here. So I'm going to add 9x to both sides. 3y equals, and then this is where you got to put it ahead of that. So 9x minus 12, and then you're dividing both things by 3. So it's 3x minus 4. Perfect. All right, let me give you just one or two more here, because I really do want to see that you're working these out. Let's go minus 8x minus 4y equals 20. Go ahead and work that out, please. Again, solving for y.
Okay. Okay, I got it.
You got it? Okay. So let me work it out here and you can follow and see if this matches your work as well. So minus 4y equals 8x plus 20 divided by negative 4. So we're dividing both these by negative 4. So it's negative 2x minus 5. Or if you put minus 5 minus 2x, that would also be correct.
I
Is that
put the first one.
great? This is what I want to see. This is how it's going to be shown in the test.
Okay.
So let's go back to our original question, which is I said, hey, Craig, here's a literal equation, ax plus by equals c, and I want you to solve for y. So watch this here. If you subtract ax from both sides, you get by equals minus ax plus c. And then you divide both sides by y. You're literally dividing everything by y. So minus a over bx plus c over b, like that. Do you see how you solve that for y?
Yep.
Okay, now let's just go back and pick one of the many problems that we looked at here. I'm going to grab this one. Okay, so here's our problem. And A is the number in front of x, B is the number in front of y, and C is the other number 6. Okay. So now if I use this equation, which some students do actually memorize it. I don't know if I think it's a good idea, but I just wanted you to see this. It's negative of a, negative of negative 4 over negative 2x plus 6 over negative 2. And that reduces to negative makes positive 4 over negative 2. So negative 2x minus 3, which is exactly what we got when we worked this out before.
Yeah.
So the point of what I was trying to get you to do, and this worked out really nicely, is that you can solve a literal equation for a variable. In fact, that's what I'm going to have you try next year. You can actually solve it for anything. So I'd like you to take this equation right here, and this time I want you to solve for x. Try solving it for x, please.
Like the same thing, but just for x.
Yep, instead of solving for y, you're going to solve for x. So you're going to move this by over, and you're going to divide by a.
Got you. Okay, come on, paper B.
Sorry about that, bro. That's all right. Didn't realize it. Oh, good.
Okay,
You think you got it?
I think I got it.
Okay, so
So-
we're gonna subtract by from both sides. And you get ax equals minus by plus c. And then you divide everything by a. So x equals minus b divided by a times y plus c divided by a.
That's what I thought. If I just put the C over A
Perfect.
before the Y. Fraction.
That's great. That's great. So this is a really important skill to master. So we're glad we got to spend a little time on that today. Is your dad available? Does he want to have any dialogue today?
Oh, yes, it's available.
Okay, why don't you grab him real quick and we'll close out.
One moment.
Hello?
Hey, Rick, today we covered my question of the week for this week. It was a story problem. We did a number of examples of that. And then I've always got two versions of it. So, or two different types of the same question. So got through that. And then I noticed there was potentially uncertainty about how to solve what are called literal equations. And this is just one type of literal equation, basically no numbers. So we worked through some numerical examples, and then we did the actual literal equations where you solve it for the letter that's indicated for it. So I thought it was a great lesson today. I'll continue to always ask Craig to work out problems. That's part of this. It's part of the building of the math muscle, so to speak.
Right.
So
We'll both make sure that he has paper and pencil always in front of him.
yes.
Now, how did he catch on with those ones that were AX plus, like you say, BY or whatever?
Yeah, I think just not seeing it, he was a little uncertain about how to proceed. But what I do is I change the problem until the student can understand a few numbers. He got it pretty quickly. And then we can
Okay.
go back to the more complicated ones, because he'll definitely see literal equations, symbolic equations in this test that he's going to take.
Okay, good. Well, that's fantastic. Sounds like another great day.
Yeah. Do you guys want to schedule for next Tuesday at this time?
Yeah, I think we should do it until the end of school. Don't you
Okay.
think, Craig? Which is about 2 more Tuesdays.
Okay. I will get it on the schedule and you'll see some booking emails.
Great. So let's do the next 2 Tuesdays, and then we will reassess, because at that point, I think school will just about be done. And then he may go up to visit some grandparents, and then he may have this other trip. And so we'll get that all ready as soon as we can on that.
All right.
Okay.
Well, sounds good. Thank you so
All right.
much,
Have
guys.
a great day, and
Yeah,
say
you
hi to
too.
my brother if you see him.
Will do. Bye, Craig.
Thanks.
Yeah.
Bye.